Okay, central limit theorem for means. So we have talked about all sampling distributions. That was 6.3. And then doing them by hand. Remember writing out all the population. Then we looked at larger populations where we didn't have to write out all of them. We just had a formula for the sampling distribution mean and standard deviation. Then we answered questions using the normal distribution. Today we're going to look at the same type of thing but with means. So here's the definition, sampling distribution for means, if you can recall. In your notes I just gave you. This is not on there. We're just talking about it. So what were those two conditions? Do you remember?
Random sample. And then it's like X minus something got an equal greater than 5.
Yes. So that was for proportions. Now we're going to look at the two conditions for means. So here we have an example. The difference between proportion and mean. Proportion is always going to be like 10 out of 30 people said this. It's going to be for categorical data. Mean is going to give you the average, and it's going to say the word average, or it'll say the word mean. So, here we have a distribution of platelet volume of patients who do not have a metabolic syndrome. It's approximately normal, a mean of 8.25, standard deviation of 0.75. So here's what it looks like. What kind of distribution is this? Normal. Then we took a sampling distribution with different sample sizes, so 5, 10, 20, 30. What do you notice about the average for all of them? What's the mean for all of them? And you can go back to the original problem.
Looks like 8.25.
Looks about 8.25, right? What's happening to the standard deviation as your sample size increases? It's decreasing. And the shape is becoming more normal. It's becoming normal.
Wait, no.
So here are the three things that we can predict or we can use from a sampling distribution. So the mean of your sampling distribution just equals the population mean. Your standard deviation, you just divide it by the square root of your sample size, and then that's the formula for z-score.
What is that?
Okay, here's the two conditions for this. So it has to come from a random sample. The second condition is that it is normal if your population is normal. So if it's given,
Like if it says.
if it's given to you in the problem. So if it's given in problem, or my sample size is greater than or equal to 30.
So we should always equal that one that's greater than or equal to 30.
Mm-hmm.
Even if it does say.
So you don't have to check anything mathematically now.
Oh, so it's just always equal to
It's
30.
just your sample size has to be greater than or equal to 30. Or it's given to you in the problem.
So how do you find it? How do you find the sample size?
It gives it to you in the problem. It'll tell you what the sample size is. Yes. Okay, so for me, I got 0.2, and then someone do 9 divided by 50 for me. That's just what I got.
0.18.
0.18.
Was it 1 out of 10?
Okay, on the actual dice, what is the proportion of ones? Or what's the probability of rolling a 1?
1 out of 6.
1 out of 6. What is that decimal?
0.166666667.
How did you get the decimals? You just divide.
Just divide. So I got 0 out of 3. I got 2 out of 10, and then I got 9 out of 50, which these are the decimals that it gave me. So what do you notice is happening the more times that I'm rolling the dice?
The less likely you are to get it.
It's not becoming more normal, but it's coming closer to the actual.
Oh.
So the more times, so the more trials, the closer to the actual proportion.
Well, mine didn't really go like that. Mine went 0.3 to 0.1, then 0.2.
Okay, do it 100 times. Then try it 100 times, or the biggest amount. Okay, then go to the biggest amount.
How'd you count that many out of 100?
Wait, we were gonna roll the dice 50 times.
We were.
There's only supposed to
I'm so glad you don't have this.
Oh my
That would have
gosh.
taken hours.
I got 10 ones again, so.
1-6. That's perfect.
We really are. I hate you today.
So, what that means, that's called the law of large numbers. So listen, because there's a lot of text and I didn't make you write it down, but I want you to listen. So just put your pencils down and watch me. The law of large numbers means, so we know that there are 1 out of 6 ones on a dice, or the chances of rolling that is 1 out of 6. That's your theoretical probability that every single time, or same with like flipping a coin. If I flipped a coin, if you flipped it 10 times, you would expect 5 and 5 to be heads or tails. So half to be heads, half to be tails. But that doesn't always happen. So if that doesn't happen, the more times that you roll the dice, or the more times you flip a coin, it approaches and gets closer and closer to what your actual proportion is. So that's what the law of large numbers is saying. When I only rolled it 3 times, it said I had a 0% chance of rolling a 1, which is not true, right? So the more trials, the closer it is to your actual proportion. That's all that that's saying. And so that's why we make our sample size 30, because 30 is the exact number that we need to create a normal distribution. So that's why we say that our sample size has to be 30.
I went up to 60 further than the number.
Do you mean 50? You said 30.
No,
You mean 30?
whenever we're doing a sampling distribution.
Okay.
I went up to 60. Oh.
It's not always going to be exactly right. Okay, here's the entire last 2 sections just separated into a table. So you might want to fill this in so that, and I think some of it's filled in for you, but let's go back and fill in the standard deviation. Does anyone remember that from the last unit, or the last section?
It's like P minus 1.
Yeah, yeah.
P 1 minus P over E.
Mm-hmm. Yes. Nope.
We're not even gonna use that in college, are we?
Yeah.
I take this again in college.
I don't know. Then what was the one that we just learned?
N greater than equal to 30. Or that would-
Oh, that's it?
Mhm.
What's the big one? Oh, Z-scores.
Okay, then the z-score.
It's like
Z or
something all over that.
no, something
P
greater.
hat minus P over square root P1 minus P over N. Then for means, X bar minus mu over sigma divided by the square root of N. Read the problem and circle the important numbers.
This is a flashback.
Yeah, it's like PTSD.
Okay, describe the sampling distribution. So, shape, center, and spread of the mean weight for a random sample of 40 customers. So, the first thing that I want to check are the conditions. Is it from a random sample?
It doesn't really say that, but you
It doesn't say it, but we assume it. So we just write down random sample.
check. Didn't it say for a random sample?
Yeah, there it is. 2, I want to say it's a normal distribution, but how do I know?
N1 minus
So-
NP.
Nope, that's for proportions. For means.
30. Oh, it has to be greater than 30.
Yep.
Is it,
That's the magic number, 30.
I thought last week it was like 0.5.
That's for a different lesson.
That's a different lesson.
That's
Oh gosh.
proportion. This is
Proportion. This is me.
So by the CLT, so central limit theorem, distribution is normal. Yes. Or a normal distribution.
What is greater than 30? What are we-
My sample
this
size.
is a mean
Oh, okay. What
problem.
does it say? It says 40.
Because it tells me the mean.
I'm sorry.
Oh,
It says mean of 210 standard deviation.
Is that all we're doing?
Then I want to find the center in the spread. So my mean of x bar is what?
210.
And my standard deviation? What's the formula?
Oh.
25 over the square root of 40. Good. So somebody put that in their calculator and tell me what you get. 3.95.
I like that.
So if we had to find the z-score for this, what would we do?
You would plug in to the formula.
Okay.
Okay, now it says assume that customers on any particular flight are similar to a random sample if the total weight of passengers and their luggage should not exceed 8,800 pounds. What is the probability that a sold out flight, so 40 passengers, will exceed the weight limit? And then it says a hint, rewrite the desired limit as an average per passenger.
Got it.
This is probability of this sort of thing.
This is inverse, normal.
So I want to do normal CDF.
Who said that?
And it says that it will exceed the weight limit. Okay, so the total weight limit is 8,800.
It will exceed, so that needs to be 8.
So I need to take,
What needs to be your min?
No, it doesn't.
No, it doesn't.
It's saying what probability that the sold out flight
will exceed.
Oh, so it's your min.
So,
So that's your
8,000
min.
is your min then.
8,000.
Oh.
So that's the total, but I'm trying to find per passenger. So what would the divided by 40?
220, comma.
To infinity, then 210,
I believe it.
and 3.95.
How far I get on over here.
Wait, why don't we put it to 5?
3.95.
No,
Oh, because we're dividing it by the samples, the square root of the sample size.
We look the same today.
I know.
Okay, what do you end up getting?
0.056.
Today.
Now, if you put in 8,800 into this, you would end up getting 0 or you would get an error or something. The number that's in your lower and upper bounds needs to be relatively close to the mean. Otherwise, you're doing something wrong. So 8,000 has nothing to do with 220. Like they're 210. They're not even close. So that means that you need to do something. Like in this case, I needed to divide it by 40. So there's a 0.567% chance that I will exceed the limit.
Oh, I was right.
Bet.
They are parameters. You use mu and sigma. Are the conditions necessary for the validity of the central limit theorem met here? The answer is yes, because in the problem, remember I said there's two ways that you got a normal distribution. Either it's given to you, or your sample size is greater than or equal to 30. It doesn't tell me a sample size here. It doesn't give me one. That's why I said 130, but you don't use that until part D. So at this point we don't know a sample size, but it doesn't matter because of this right here. So out of the normal condition, it could either be given to you, and at that point it doesn't matter what the sample size is, or your sample size is greater than 30 if it's not given. So here it is given. The population is normal, then you have a normal sampling distribution. For part C, calculate the probability that A randomly selected healthy adult. So how many is that?
One.
Just one. Like N equals 1 here. That one person is between 98.5 and 98.7. If you're only doing one of them, then you just use the mean and the standard deviation. Because it's like taking it over the square root of 1, which is the same thing as just 1.
Oh, no.
0.113.
I did 0.115.
What are you saying?
So close to you.
Yeah, okay, so sometimes you have to do that in the square.
So then the next one, it asks about a sample of 130.
Asking for 1%. But now, we just did it, but now it's asking for 130.
So what would change?
The standard deviation.
Good. 98.5, 98.7, 98.6, and then 0.7 divided by the square root of 130.
Oh, okay.
We'll know to do that when n is not 1.
Right.
Because if n is 1, it's the same.
It's just like over the square root of 1.
And every time we do a normal CDF problem like this, we do that.
Mhm.
Did we do that on the last one?
Yes. Yes, we did, guys.
No.
Oh, wait.
We did.
Yes.
That's why I was
Look,
very
guys, right here. Right
It's
up here.
0.06.
Oh.
0.06?
Oh, wait, no.
You just
I was
don't do the standard
doing
deviation.
divided by-
Oh.
I thought that was just known.
Uh-oh, this calculator is going
Okay.
It's what?
0.9. So you always have to do
Point what?
deviation.
You need to put your values in there.
Okay, okay.
I'll put them in there.
Okay, next part it says suppose we did not know that the population was normal. So basically, suppose that it was not given to us. Would your calculations be valid for B and or D?
No.
No.
Yes. Oh yeah, because 130 is greater than 30.
So for D,
For
Yes.
They didn't give it to you till D.
because N is greater than or equal to 30 in part D. But for part B, N equals 1,
So no.
and it's not given, so no. Because N is less than 30 and it's not given. And then in part D, it doesn't matter if it's given because my sample size is greater than 30.
I understand this.
I'm glad you do.
I teach you.
Okay, try example 3 from start to finish. Just A, B, and C.
Spread is you take the sample
Okay, that makes sense.
Hey, Riley.
Okay, here's what I got for example 3.
over the standard deviation that's given.
Oh, so be 7 and 14.
Once you get that, try 4. We've only got 2 more, so try 4.
Scared me. I didn't know what you were doing. Try 4.
When you have a problem that's just one question, you would think, I just need to find the answer. But you cannot use normal CDF until you prove that it's normal, which are these 2 conditions. And if you don't write it in this entirety, I will count off points. So if you just put 36 is greater than 30, or you just go straight to the normal CDF, it's going to be wrong. Which doesn't seem fair, but that's just how life works in this class. What does that tell me? But you didn't tell me that you proved that it's normal. You just told me 36 is greater than 30.
I proved that it is normal.
Mm-hmm.
You have to write that.
That I put all of them on this side.
Okay, normal CDF, I know you have to divide 7 by 10.
Okay, last one, try 5. So the bottom space is to prove it's normal, and then parts A, B, and C are on the back.
Selected, that means 1. So 1 is your N.
Yes, so population is normal, so sampling distribution is normal. Write that. Then I give the mean and the standard deviation for A randomly selected. So that would just be like dividing by the square root of 1, which is just the
I'm
same
doing it
thing.
right now. I'll tell you in a second.
That's not bad.
Okay, the population is normal. Is that what you have to write to prove it?
Yes. When it's given, I want you to write this nice, pretty sentence. Give me the mean and the standard deviation.
The population.
Don't just put given.
I said normal distribution
If we're
because
like
it is
a word
given.
off, are you gonna still count wrong?
Does that count?
But what's given? It's given that the population is normal.
Okay.
I don't understand why that's necessary. It's okay. That just is I'm sorry, I didn't really need to say it like that. But I
It's
said
because you're
okay.
not really proving it unless you say this kind of phrase.
If I'm
Like, I know what you're trying
One
to
word
say.
off.
No, I mean if you're getting the point across, then it's okay. But if you're saying this is what I implied, yeah,
Normal, so.
nothing is necessarily implied when I'm reading it. It's like I'm a first grader that's never seen it before. Okay, the last thing. So it says, would this result be unusual?
Because it's so far.
Yes, because the probability is less than 5%. So something is unusual if it's less than 5% of the time.
Why can't you just say it's less than 30?
Well, it's given the population is normal in the problem, so it doesn't matter if the sample size is 30.
Is that the probability?
Yes.
We're finding.
So this is like a 3.5% chance of happening. This is a 0.5% chance of happening.
Oh my.
I don't see a math lab.
Oh, you moved it as a motherfucker.